Hello everyone, welcome back. Today we're going to do some questions from physical quantities and measurement to density, and we're going to discuss each question so that everyone gets an insight on how to attempt these questions, these real life exam paper questions. So let's start. We're going to start with the MCQs first, and then we're going to move on to P2 style questions. Okay, so the first question is, the diagram shows arrows representing two vectors. We can see the two vectors here, the first one and the second one. Which diagram shows the resultant R of these two vectors? Okay, so you know how I do this question is I try to visualize these vectors. So for example, if I have a ball here, okay, one force on this ball or one vector on this ball is towards the right, and the other one is towards this direction. Okay, so I know that if I have a ball and I've got these two vectors acting on it, obviously the resultant vector on the ball can't be in, for example, this direction, or it can't be downwards, or it can't be in this direction, because it is obviously in the opposite direction to the vectors that we've drawn. So we know that the resultant vector is going to be in somewhat this area. Okay, so let's try to cancel out as many options as we can by using this logic. So in the first one, the A option, we can see that the resultant vector is towards this side. However, we discussed that if we just apply a little bit of logic, we can see that obviously the vectors can't have a resultant vector in this direction, so we know that A is wrong. Okay, moving on to B. For B, we've got the resultant vector in this direction, and as we can see, this is also not possible, because we don't have any vector, like these two vectors aren't acting downwards, so our resultant vector can't be downwards, so B is also not the correct answer. Okay, so then we've got C. C is towards the left. However, if we look at the two vectors that they've given us in the question, we can see both of them act towards like the right or the top right side of your page, so it can't be that the resultant vector is towards the left. So we also know that C cannot be the correct answer. Now if we look at D, we can see that the resultant vector in D is in this direction, and the resultant vector is towards the right, which agrees with the vectors that they've given in the question, and it's also a little bit upwards, which also agrees with the two vectors that they've given in the question, because if you look at this vector, it's towards top right. Okay, and this one is towards right, so this vector in D, it's towards top right. Now it's not disagreeing with any of the vectors that we have in the question, so my logic tells me that this is the answer. Okay, so moving on, the question 2 says, which set of quantities are all vectors? A, acceleration, displacement, velocity. Okay, so from the looks of it, this option looks correct. Let's go on and look at the other options. B, chemical energy, mass and power. So we know that mass, chemical energy and power, none of these is a vector quantity. C, extension, force, gravitational potential energy. Energy is not vector, so this is also incorrect. If you look at D, weight, kinetic energy and work. Work is the same as energy. Okay, if work is not okay, so with the D part, we've got weight, kinetic energy and work. Energy once again is not a vector, so our correct option is A. Okay, so for the third question, we've got a student determines the circumference of a golf ball. Which instrument gives a reading that is the circumference of the golf ball? So for example, if you've got a golf ball here like this, the circumference for it is going to be the length around the golf ball, so this length. Okay, now we need to measure this length. So we know that the circumference is a circular length, so we need something which is flexible to measure it. Calipers is not a good option here, because it only measures in a straight line. So does micrometer, and so does the rule. So our correct answer is D, tape. Okay, moving on, for question 4, they say that the graph shows how the speed of the car varies with time. Which statement about the acceleration of the car between 10 seconds and 20 seconds is correct? Okay, so first let's try to understand what this graph is representing. So we've got a car which is starting from rest, as we can see, because at time 0 the speed is 0. The car speed starts to increase as time progresses until this point right here, on which we can see that the car speed becomes constant. Becoming constant means that it's not accelerating anymore, the car speed just becomes constant. However, before that, from 0 to whatever the speed is, the car speed was increasing, so the car was accelerating. So for this portion right here, we can say that the car was accelerating. That is why its speed increased. But after this, the car speed became constant. So this whole area, the car speed is constant, which means no acceleration. Okay, now let's see what the statements say. A, the acceleration decreases. Now remember that they're talking about the movement of the car between 10 seconds and 20 seconds. So the first part says, A says that the acceleration decreases. Now acceleration decreases means that the car is still accelerating, just at a lower rate. However, this is not true, because as we can see that there is a flat line, the speed is constant, and as the speed is constant, the car is not accelerating at all. So A is going to be wrong. As for B, the acceleration increases. This will also be wrong, because as we know, the car speed is constant, so there is no acceleration on the car. Okay, so for C, the acceleration is constant but not 0. This statement is also incorrect, because as we know, the car speed is constant. It's not increasing. There is no change in the car speed, so the acceleration has to be 0. So C is also incorrect, and the D part says that the acceleration is 0, which is the correct answer. For the fourth question, they say that the car has stopped at a red light. When the light changes to green, the car starts moving with a constant acceleration. The graph represents this motion. Which quantity is plotted on the x-axis and which is plotted on the y-axis? Okay, so very important words that we need to remember in this question is that they say that the car has constant acceleration. Constant acceleration means that it accelerates at a constant rate. The change in velocity is constant. Okay, so to solve this, we need to understand what does constant acceleration means in terms of graphs. So if we look back at our videos of motion, we will remember that for speed time graphs, this is a speed time graph. If the acceleration is constant, the graph is always a straight line. It is always a straight line, and it can have a gradient, but it is always a straight line. Okay, but if we talk about distance time graphs, for constant acceleration, the distance time graph will look something like this. Now if you compare the graph that we've drawn to the graph that they've given, we can see that the graph correlates to the distance time graph. So on the y-axis we'll have distance, and on the x we'll have time. So we'll have distance and time, and we can see that C is the correct answer. Okay, so question number 5, which statement about mass and weight is correct? A mass experiences a weight due to gravitational field. Okay, so that sounds correct, because weight is a force, and this force is due to the mass and the gravitational field. So okay, this sounds correct, but we'll look to the other statements as well. Mass and weight are different types of forces. Okay, we know that weight is a force, but mass is not a force, so this is incorrect. Mass and weight have the same unit. This is also wrong, because we know that the mass has a unit of kg, while weight is a force, so weight is measured in newtons. Okay, moving on. So this is also wrong. D, when an object expands, its mass changes but its weight stays the same. This is also incorrect, because when an object expands, there's a change in volume, not mass. So whenever an object expands or contracts, its volume changes while its mass remains the same. So this is also incorrect. So the correct answer is A. Okay, so our next question says a skydiver falls from rest through the air and reaches terminal velocity. What is the acceleration of the skydiver during his fall? So before we solve this question, we need to understand what happens to the skydiver when he starts his fall. So the moment the skydiver jumps out of the airplane or whatever he's on, his velocity is 0, okay, and his acceleration is 10 meters per second squared. Now the velocity is 0 because his motion has just begun, so he doesn't have any velocity, and the acceleration is 10 meters per second squared due to the gravity, as we have talked before in our motion videos. So in the start, his acceleration is 10 meters per second squared. So after starting, due to this acceleration, his velocity starts to increase, and as his velocity increases, so does the air resistance against this um, skydiver. So for example, if the downward acceleration, gravitational force is in downward direction, as his velocity increases, he starts to face air resistance, and the air resistance acts upwards, and as his velocity increases, the air resistance also increases, and there comes a point where the air resistance is becomes equal to his gravitational force pulling him downward. So the net force becomes 0 and there is no acceleration on the skydiver. So basically in the start his acceleration is 10 meters per second squared, and slowly it starts to decrease, and there comes a point where it becomes 0. The point where his acceleration becomes 0, you have to check what velocity that is, and that velocity is called terminal velocity. Now coming back to the question, what is the acceleration of the skydiver during his fall? Constant at 0 meters per second squared? No, this is incorrect because in the start he has an acceleration of 10 meters per second squared. Okay, constant 10 meters per second squared. This is also incorrect because his acceleration decreases due to air resistance, starting at 0 meters per second squared and increase to 10 meters per second squared. This is also incorrect because, as we know, in the start his acceleration is 10 meters per second squared. D, starting at 10 meters per second squared and decreasing to 0 meters per second squared. This is the correct answer. Okay, so the next question says the graph shows a distance time graph for a car traveling in a straight line. In which region is the car decelerating? Okay, so let's talk about what is the effect of deceleration on a distance time graph. So for example, I am going to make a distance time graph here. This is a distance time graph. If your car has a constant velocity, your distance time graph will start to look something like this. It will be a straight line with a constant gradient. If your car starts to accelerate, the gradient will start to increase, so the line is going to become curved upwards. However, if the car starts to decrease, the gradient is going to if the car starts to decelerate, the gradient is going to decrease, so your line becomes curved in a downward slope like this. So you can say that this portion has a constant velocity, this portion is accelerating, and this portion is decelerating. So we just need to see what part of the graph represents the decelerating portion, and if we just look a bit closely, we can see that C has a decreasing gradient, so it becomes our correct answer. Okay, so in the next question it says a micrometer is used to measure the diameter of a uniform wire. What is done to obtain an accurate answer? Okay, A, make the micrometer horizontal and then use the scales to find the reading. Well, honestly, the orientation won't make a difference at all in your reading, so this is not the correct answer. B, subtract the fixed scale reading from the rotating scale reading. We know that this is not true because we actually need to add both of those readings, so this is also incorrect. C, subtract the rotating scale reading from the fixed scale reading. This is also incorrect. And D, use the scales to find the reading and add or subtract any zero error. And this one is correct because, yes, of course, we'll use the scale to find the reading, and then we need to add or subtract any zero error to get an accurate answer. So D is going to be the correct answer. The next question says a car's acceleration and maximum speed are improved by using an engine of smaller mass and greater driving force. How many of the underlying quantities are vectors? So we know that the first acceleration is going to be vector, speed is not vector, mass is also not vector, and force is a vector quantity. So our correct answer is going to be V. So the next question says the diagram shows the resultant R of a 3 Newton force and a 4 Newton force acting on a point. The angle between the 3 Newton force and 4 Newton force can only be any value from 0 to 90, which value of r is not possible. Okay, so it's for example, we have two extreme scenarios. The first one will be that the 3 Newton force and the 4 Newton force will both act at 0 degrees, so 3 and 4. In this case, our resultant will be 7 newtons, so this is going to be our upper bound. Now for the lower bound, in case 3 Newton force acts in this direction and 4 acts in this direction, we can use the Pythagoras theorem to find out uh, the length of our r vector, and that's going to be 5 newtons. So we know that our calculated force has to be in between 7 and 5 newton. It cannot be more than 7 and it cannot be less than 5. So 4 is not a possible answer. The next part says the speed time graph represents a short journey, which distance time graph represents the same journey. Okay, so if we try to analyze the speed time graph, we can see that the speed is constantly increasing, which means that the object or whatever it is accelerating. Now we just need to check our 4 options and look at the distance time graph, which represents an accelerating object. So as we've talked before, the graph for an accelerating object, the distance time graph actually for an accelerating object looks something like this. And if we take a closer look, we can see that A is the correct answer, while C, B and D are not. Our next question says an object travels for 20 seconds with a constant speed of 10 meters per second. For the next 10 seconds it accelerates uniformly to 20 meters per second. What is the total distance traveled by the object in 30 seconds? So the total distance is the area under the graph. Now we're going to calculate the area under the graph. So to make this question a bit easier, I'm gonna divide this in two parts. First you have a rectangle, so the area of the rectangle is 10 multiplied by 20, so I get 200 meters here. We have this shape, and the formula to calculate the area of this shape is 1 over 2 multiplied by the sum of the lengths of the two parallel sides, which in this case are this and this. So this will become 10 plus 20 multiplied by the height between those two sides. So the height, this is the height we're going to talk about, and this is 10. So if we just solve this, we get 1 over 2 30 multiplied by 10, 2 1s are, 2 5s are, and 150 meters. Now we're going to add both of the distances that we've calculated. So we're going to add 200 into 150, and we get our final answer 350 meters. So B is the correct answer. The next question says the diagram shows two objects on a beam balance. The beam balance is in equilibrium. Which quantities may be different? The masses of the two objects, the moment about the pivot of the two objects, the volume of the two objects, the weight of the two objects. So as we can see, both the objects are balanced, and they're balanced means that their mass is same. It also means that their weight is same because they're both on the same planet. Now let's apply this to our options. A, the masses of the two objects. The masses are the same as we've talked about, so A cannot be the correct answer. B, the moments of about the pivots of the two objects. We haven't studied moments yet, but just to give you guys a heads up, so moment is the turning effect of a force. So the weight of this rock has a moment in this direction, and the weight of this rock has a moment in this direction. Now as both of the moments cancel each other out, that is why the objects are in equilibrium on the beam balance. So B can also not be the correct answer because the moments need to be same for them to be in equilibrium. C, the volumes of the two objects. Okay, we are going to talk about this later. And D, the weights of the two objects, and as we know, the weight is also constant. Now C is the correct answer because volume isn't related to mass. So the volume can be anything as long as both the masses are same. So we know that C will be the correct answer. Okay, the next question says two blocks are joined together. One block has a density of 6 gram per centimeter cube and the other has a density of 9 gram per centimeter cube. What is the overall density of the two blocks joined together? So density is equals to mass over volume. So we need to calculate the mass for both the objects, and then we have to calculate the volume for both the objects, and then we're going to put it into this formula, and then we're going to calculate the density of the total two blocks joined together. So let's solve for mass first. So the mass of this gray box we're going to calculate by using its density. So they have told us that the density for this box is 6 grams per centimeter cube, and we need to calculate the mass, and if we calculate the volume is 1, so we know that the mass is 6 grams. Now for the other white side, we've got the density as 9 grams per centimeter cube. We need to calculate the mass, and the volume in this case is going to be 2 centimeter cube, because, well, this side multiplied by this side multiplied by this side becomes 2. So we've got the mass as 18 grams for the white box. Now the volume we can very easily calculate. The volume for the gray box is 1 centimeter cube, and for the white one it is 2 centimeter cube. Now let's put this into our formula. Density is equals to mass. The total mass is going to be 24 over the total volume, which is 3. So D is equals to 8, and C will be our correct answer. Okay, so the next question says a manufacturer measures the 3 dimensions of a wooden floor tile using 3 different instruments. The appropriate dimensions of the tile are shown. Which instrument are used to measure accurately each of these dimensions? Okay, so we know that the length is 0.4 meters. It is less than a meter, so obviously we're going to use a meter rule here. The thickness is very small, so we need something very precise to measure the thickness, and that is going to be micrometers. The width is also small, but it isn't as small as the thickness, so we need something which is precise but not as precise as the micrometers. We can use vernier calipers here. So if we just put this and look at our options, for length we need the meter rule, so yes, A and B can be our correct answers. For thickness we need the micrometers, and for the width we need the calipers. So A is our correct answer. Thank you for watching. I hope that this helped a lot, and if you've got any questions, feel free to put it down in the comment section below. I'll soon make another video for the P2 style questions. Once again, thank you. Have a good day.